to begin with some slides, and based on the slide, we will discuss how 5G in ORAN looks like, and what is the importance of 5G, and how it is different in ORAN compared to the 3GPP 5G architecture. So our discussion would be based on around these topics. Let's start with this topic for today, and I have uh, categorized this three agenda topic for today. First, I will start with Rakuten Symphony and Rakuten Group introduction, because although we delivered many sessions for Asia Open RAN Academy, but this might be the new batch, the new people who are joining today. So it should be good to know a little bit about the Rakuten and from where I belongs to. And next, I will start with the 5G fundamentals and ORAN based on 3GPP and 5G requirement, and then we'll eventually will switch to 5G Open RAN, and I will also try to explain the differences in architecture from 3GPP 5G to ORAN lines. Okay, uh, and also this Open RAN setup, how it will benefit the customers, and uh, how we can leverage the Open RAN and virtualized environment, the cloud native environment. And if you compare with the traditional 5G RAN, how virtualized and Open RAN 5G is different. So our focus will be would be more on this side. Uh, let's begin with the slide, and this is okay. All right. So this is the first slide. Just to show the audience our presence, our Rakuten presence in different countries, and we have more than 35 plus companies uh, uh, under Rakuten Group. So in telecom, we have two companies, that is Rakuten Mobile and Rakuten Symphony. Rest you can see the Rakuten Viber is there, Rakuten Equifax is there, Rakuten Kobo is there. So so overall, we are offering 17 plus services and businesses. We are present in 30 plus countries, regions around the world. We have 1.6 billion global members, and total annual revenue in 2001. It's a whole slide actually. It was 15.3 billion. Okay, dollar. So this is just about the Rakuten at the glance, and the next slide is on our vision. So this is from Rakuten's CEO and Rakuten chairman, that Rakuten want to empower the people so that they can realize their dreams. All right, and our vision is aligned with the CEO vision, and we are working towards towards his vision, so that it can be easy for opcos, for enterprise business to leverage the offering from Open RAN, and they can use it. All right, and so that the people can be empowered. All right. Now with the simple difference, what is Symphony and what is mobile, Rakuten Mobile. So these are the two mainly in telecom out of Rakuten Group. So you might also have confusion. You have heard about the Rakuten Mobile or RMI and Rakuten Symphony. So basically, Rakuten Mobile is a mobile operator uh, in Japan, and this is a fully fast virtualized cloud native mobile network. Okay, this is based on the Open RAN. So this we have started in Japan for 4 years back, and it was the first operator which which deployed the equipments well before target timeline, and currently we have covered 99.9% of population, and our network is well performing there. We are even in the recent survey from Open Signal, we have in some categories in download and upload speed, and in quality we were the number one. Okay, so it's performing, just not the only the talk about the opinion. It's performing well, and this all is proven by the different companies in the different companies and enterprises, and we also received many award from them. Symphony is a company which is offering the experience what we have learned in the Rakuten Mobile. So obviously it's Open RAN only. So we are offering the experience of Rakuten Mobile to the telcos and to the enterprises all around the world. Uh, uh, Again, the offering or offering should be the Open RAN and fully virtualized. And we are we are approaching new customers, the greenfield customer, the brownfield customer, and we are explaining them that how the Open RAN can save the capex, save the opex, and how it can increase the user experience. Okay, and also the timeline of network deployment, how it can be increased. So we are just showing the experience whatever we have learned and we have achieved in the Rakuten Mobile. Uh, so this is about the Rakuten Symphony, and the vision and purposes is straightforward. We are wanted to connect the everything to fulfill its potential and sustainable future. And after that, we can switch to the 5G fundamental. This is the second agenda of our today's session. Let's start with the overview and the fundamentals. So this is the first thing. If you compare this, if you compare the different technologies which we have, starting from uh, maybe 2G Edge. So Edge was Edge was for data, and if you compare the HSPA or HSDP, HSUPA, what data rate we were getting was around zero point 0.4, 0.04 Gbps, and in LT it was zero point 0.1, and with the Cat 4 it was zero point 0.1, 0.15 Gbps, and now with the LT Advanced we are getting around 1 Gbps, right? Uh, that is multiple new technologies we need to use to achieve this LT Advanced 1 Gbps throughput. Okay, this is in idle condition. Maybe someone can say that how we can get this in LT, and what is the use of 5G. So this is just a comparing chart that what we can achieve here in a best suitable condition, and what we can achieve in 5G with best suitable condition. So this is what we are getting. We can give it to the 5G. It's a 20 Gbps. All right. So this is a simple chart to explain the need of 5G and what peak data rate we can achieve in 5G. Okay. Hope this slide is clear, very much clear from its graphics. Now going forward to the next one, and this is all about uh, the things which we are doing now. So if you compare from the beginning, the telecom where we started from 2G, 3G, and 4G. So initially we were thinking about only the connecting the people, so that everyone can connect, can talk to each other, and can share their emotions, they can talk to their loved ones through the initial technologies which the telecom has offered in 2G. Uh, Now we have evolved from 2G to 3G and then HSDPA, so that was more focused to the data. Now we are in LT, and we have also launched many in many countries the 5G. So we are talking about the now that we are talking about the programmable world, where we are approaching to improve the personal life and optimizing the business processes. So 5G is all about improving personal lives and improving the business processes. All right, that all can be achieved through greater automation, enhanced connectivity, intelligence operation, and through which we can help industry to become more efficient, more agile, and real time. Right. So this all is about 5G. Now, to understand the gap from 5G to LTE, there's a simple slide where we can see, and someone might have a question that why we cannot enhance the softwares, the hardwares in LTE and get the features and the data rate what we can achieve in 5G through LTE only. What is the need of 5G? So we'll have some. This is a table which will explain the gaps what we have initially. So in the user experience data rate, we can get 100 Mbps each user in 5G, and in LTE there is no uh, fundamental straightforward data rate which we can commit to the customer. It's based on the network congestion, network utilization. The LT users can create. Sometimes it could be 10 Mbps, sometimes it could be 40 Mbps, and sometimes it could be 1 Mbps as well. Right. Now the if you talk about the peak data rate, so we can get downlink 20 Gbps, uplink 10 Gbps, and in LT in good condition we can also get 1 Gbps and zero point 0.5 Gbps in uplink. Spectral efficiency is downlink it's 30 bits per hertz, less in LT. So these are the main differences, main gaps. Latency wise, since there is a three main pillars of 5G, there is a EMBB, the mobile broadband, URLCC, and EMTC. So for mainly for URLCC, the latency latency is very less, and that is zero point 0.5 millisecond. And for EMBB, it could be 4 millisecond, and for control, it could be 10 millisecond. But in LT, we can only get the minimum for user plane is 10 millisecond, and for control 50 millisecond. So now you can consider whatever you can enhance the software wise or hardware wise in LT, it cannot achieve the latency what you are required in URLCC. I will explain you in a little bit what is the use of URLCC and EMBB maybe in the coming slides. So you can see here there is a clear difference, the gap why we require the 5G. And the reliability wise, it's 99.99% available, reliable, but in reality it was not specified. Means there is no commitment. Connection density would be 1 million per square 1 million customer per square kilometer, and this is all about the mobility would be 5 kilometer per hour speed. If you're running with this speed, you can get the network in well behave quality, and the handovers will be smooth. In LT, it was 350 kilometer per hour. Right. Now, whatever the software or the hardware we are using in LTE, that will not run because of this gap. So you cannot increase the hardwares or softwares and can achieve the 5G. This is what I explained from the table. So the things which we are leveraging from in the 5G is well-known techniques such as software-defined network function virtualization, and cloud computing. This all come together and allowing unprecedented flexibility in the system, in the 5G system, right? And this also enabling the network slicing features and all. So that is very good features which is only available in the 5G, which cannot get in the LTE, right? So these are major gap which we can explain here, and this is what I was trying to explain, that the three main pillars of as per 3GPP and Oran Alliance, where 5G is focusing on. So first one is enhanced mobile broadband, or EMBB. This is mainly focusing to get the more and more data reach, right? So we are achieving, as I told you, that 20 Gbps we are achieving here, uh, which can give you the 3D video and USD screen and all, because the data rate will be high. We can work and play in the cloud, right? Augmented realities and all. The next one is URLCC, which is also known as ultra reliable and low latency communications. So this is very critical because this will require very low latency communications. So mainly the self-driving cars, the mission critical applications like the healthcare. Okay, one doctor is sitting in maybe the US, and the patient is in Philippines. So through this robotic surgery, it can be possible that the remote surgery is possible. The doctor can be sitting in any country and can do the operations in different country. All right. So these are advantages or use cases we can get from this meeting. Also, the industry automation. So everything will be automated. Let's say you order one packet, so there is no need to there is no any human intervention required in the industry. Automatically the machine will pick up the item and it can dispatch, right? So you don't need to pack everything. It's already packed and stored. The machine will pick up those items as per the order. If you order, let's say, the potato, the 1 kg potato, it will be already there, and it will pick up from there and go to the delivery counter. So most of the things will be automated. So this simple example, if you consider the car manufacturing company or bike manufacturing company, everything will be automated. You don't need to do even the quality check. It can be done from robots only. The next pillar is massive machine type communication, or it's called EMTC. So machine type communication is mainly for sensors. So can be useful for smart cities. So if you're making a smart city where you want the thing is automated in your city, in your society, there will be CCTV camera, there will be video surveillance, home automation, the car parking, the the energy generating stations, renewable energy generation stations, and the Wi-Fi systems and all. So this all will be the automated through this EMTC, because there will be many and many sensors. Uh, one thing will be connected to another thing through the sensor. So let's say if someone is identified, the maybe the VIP person, and he's entering smart city. So first it will identify identify by the video surveillance, and there will be the face recognition cameras which can recognize that same person is coming, and then based on the that everything can be changed, and based on their personal experience, the things can be changed, right? So, a smart home, smart building is also part of massive machine type communication. So, these are the three use cases, main use cases of 5G as for 3GPP, and this is how we are moving ahead with the 5G. Now, the next is the use cases where we are. The Rakuten is approaching for the deployment scenarios or deployment. So I was explaining that, let's say, if in Philippines there is one operator, and the operator is deployed on 4G, and since the 5G is here, and uh, I explain you the gap from 5G to LTE. So eventually, operator has to move to the 5G. Otherwise, there will be the deadlock condition for the LTE, because there will be many feature and functionalities, and the data rate which is required by the user to fulfill the user experience cannot be fulfilled by the existing LTE networks. So what they need to do is they need to eventually adopt the 5G. Now there will be multiple scenario to adopt the 5G, and 3GPP explain the multiple options: option 2, option 3, option 3X, option 3A, option 7, option 5. So these are the options where the operator can choose and move to the 5G side. One of them in option three is in option three family is NSA. So there is two scenario for the 5G deployment. One is non-standalone deployment, and another is standalone. So non-standalone means you can use your existing 4G network, and you can deploy the 5G. So both will work, both will complement each other, and user will get the good user experience, and the data rate can be increased, will be increased. There is one. Also, some of the use cases you can activate, and the major thing is you can use your existing EPC, the core network, with NSA architecture or NSA deployment. Okay, so this is for the brownfield operator who is having 4G and they wanted to adopt 5G, so they can move with the NSA. All right, so through this they can also use their LT network, and they can leverage their existing equipments, core, RAN, everything, and even the transport can be utilized. This is one option. So we are also helping Rakuten Symphony is helping the operator with this option. So what we are suggesting them is to upgrade their radios to 4G and 5G, and virtualize RAN with the existing EPC. So if obviously before Rakuten Symphony, uh, no traditional vendors has offered virtualized RAN. It was the BBU on site. Okay, everything was on site. There was a base unit, baseband unit on the side, and the radio and the antenna, right? And it get connected with the core network at the centralized location. But since Rakuten is a virtualized network, everything will be in the cloud. So the operator need to upgrade the radio and the virtualized RAM. They can use the existing EPC. The second option is if they wanted to go ahead with the SA, because standalone have their own advantages. The use cases like URLCC, the lower latency, and the AMTC can be achieved through SA only. Right. So the most advanced thing features can be achieved through standalone, because the core network capability it has. In standalone, the core network is also going to be changed. So it will be 5GC. Right. Now you cannot use the EPC in SA mode. Sorry. So for 5G adaptation to the operator, let's say that Philippines operator who is having 4G network. Now, if they want to go with the 5G SA, they need to upgrade their radio to 5G only. So it will be standalone. It will don't have any connection with the your existing 4G network. It will be standalone. They will upgrade their radio to the 5G NR. They need to upgrade their core and they need to upgrade their RAM. So everything need to be upgraded in standalone scenario. The next option is private network. So this is mainly for the enterprise network, enterprise businesses. Let's say if you have a railway network or airport or mines or any big universities, they wanted to deploy their own network. Okay, they don't want to get the signals from the traditional or the existing operators. Okay, maybe the security issue or maybe they wanted to use some certain use cases from their own side, so they wanted to go ahead with the private network. So as Rakuten Symphony, we are also offering this deployment scenario to the customer. Now with this, the we can provide so the advantage is that we can provide private network on 5G as well as in 4G. So any of these technologies can be offered to the individual enterprises. Yes, it can be any of them, which I just explained you: the railways, the airport authority, the mines, or the different big universities. They can deploy their own network. It's very lean. It's a network in a box, so everything will be in a simple box, in a small box. Okay. The other option is multi-tenancy, and where the management can be possible from a single location. So let's say this is mainly for the scenario where you have a there is a maybe there is a one parent company who have their opcos, their operations in different countries, and let's say they have their headquarter in Philippines, and they wanted to manage the network from Philippines only. So what they can we are offering the multi-tenancy features to those kind of operators. So we will gather real-time information from all those opcos, and it will relay in the Philippines for in their HQ, and from there it can be managed. So the share infra and the operation securely with the multiple operator within a region is also possible. Second option, let's say in this scenario, in second option, in one country, if the operator have merged or have agreement to merge or to share the network, then multiple operators management can be done from one centralized location. They no need to monitor their network from individual operators. It can be done from one location. So this is called multi-tenancy. So we are offering this one as well, and as well as the international opcos from one location monitoring. Right. So these are the use cases from Rakuten Symphony, and if I'll explain you the 5G solution stack which we are offering to the customer. So it started from the hardware. So first is hardware, and so Open RAN is all about the openness and avoid or reduce the vendor locking. Now, if you compare with the traditional operators, traditional not operator, traditional OEM or vendors, they used to have their own radios, their own software stack, their own baseband unit, their own core, their own everything. So it was coupled uh, hardware and software. You cannot say that, hey, please use this OEM hardware and mount your own software. They will not agree because their software and hardware is coupled. But with Open RAN, what we're offering is to the operator is they can use their own hardwares, own COT servers, okay, any cloud. It could be from Google, it could be from AWS, it could be from VMware, it could be from Robin.io, okay. And so what this cloud did? Cloud has virtualized this hardware unit, okay. So this one hardware has been virtualized now to host the applications, and now applications are 5G and LTE DU. Okay, so the architecture is now split into DU, distributed unit, and centralized unit. So this combined is one RAN. Okay, so this is the RAN. Earlier the RAN was one unit, only BBU. Now we have two unit. Hope this is clear to you. The video distributed unit, virtualized distributed unit, and the virtualized centralized unit. Now this is RAN, and this we are complementing this RAN with the RIC functionalities. Okay, these are and its own functionality. So the application, the third party application, will be automated, and the many services will be automated because there will be the functionality of the framework where the application will be distributed uh, through real time, near real time, and real time functionalities. Okay, so instead of keeping in one location all the features, we will segregate it into the real time and non real time. Okay, so the non real time features will be on the SON side, on the SMO, not SON, and the SMO side, and the real time functionality will be on the RAN side. So this is how the REC will work, and we are also complementing it with the SON. SON is self-organizing network, and then there is a multiple things like DU, RU. RU is the same. You can call it as radio unit or RRH, which we are calling in traditional. So here is the ORU, Open Radio Unit, and this is simple. Now you understand the architecture or the end-to-end solution, how it construct. Now, so one more thing, this all the network and cloud will be managed by the third pillar or third use case, which is known as the OSS. So we have OSS or EMS, which offer the advanced automation and touchless operation, which we also call as zero touch provisioning, right? So you no need to even touch the system for bringing up the site. We have the zero touch provisioning offering through our OSS and full automation. Okay, everything is automated. Even drive test is automated. Log files are automated. Optimization is automated. We have the advanced analytics and AI ML features. It also suggests the it also gives you the prediction when site quality is going to be down and which cell need to be more focused because of due to their bad condition or due to the higher traffic, and which cell traffic can be traffic could be shifted. Let's say if there is one cell which experiencing the lower traffic, and in the same site the another cell is experiencing high traffic. So through this provision we can transfer the or migrate the resources from unused cells to the high capacity cells. All right, so this is all is done through the full-fledged automation which we are offering from our OSS, or we call it as SimWorld. Now, the benefit wise, there's a traditional RAN where the radios, as I told you, radios was proprietary. You cannot use any other vendor radio. CPRI was proprietary. You cannot use any other CPRI. Baseband unit was proprietary. The software hardware was proprietary. Infra was insufficient because of because one vendor is doing all the research and all. But here in Open RAN, many and many vendor in ORAN ecosystem is doing the research work and bringing up base of the breed technologies. So we have the multi-vendor operability, open network, open interfaces. We are because we are offering open low-level speeds, the multi-vendor operability because we have the video split architecture, video and VCU. You can use any operator video and VCUs. You can use any COS hardware and cloud because we are offering the Kubernetes CNP functionalities, and there is no vendor locking because it's openness preventing the vendor locking. Now, the momentum with Rakuten Open technology. So this is the locations we are present globally, and we are doing the business. So more than 40 global operators are engaged with Rakuten Symphony to transfer their networks, and the Rakuten Symphony technology driving the innovation end-to-end cloud-based Rakuten radio access. It's a proven commercial scale and carrier network because we are deployed in commercially deployed in Rakuten Mobile and also in Germany and in Canada uh, as well as in India. So also in Italy. So these are the commercially deployed, and some of them is the POC which we are doing with multiple operators. Okay. So, these are the greenfield and brownfield customers, including this, Airtel, VIL, TF, all right, Rakuten, and TIM. TIM is Telecom Italy. Now to simplify, so this slide I have created for you guys. I got to know that many of you is not familiar to the Open RAN 5G Open RAN. So I created this slide for you guys so that you can easily understand how the stack will be mounted in Open RAN because this is different from the traditional RAN. There you used to have multiple things, multiple equipment, but here you will have one equipment. So here is a radio. Here is a server. Okay, I told you this server could be from anywhere, any vendor. It could be from Supermicro, it could be from Dell, it could be from HP or Mitech. The only condition is the hardware should be based on x86 Intel based chipset. Right now, cloud virtualization, as I told you, any cloud you can use. It give you the cloud Kubernetes platform, and you will have your uh, your hardware virtualized through the cloud virtualization, and now you can use logical apps. So because capability wise, Rakuten Symphony can use same hardware to host 4G and 5G. So that's why, as well as a small cell. That's why we are showing here. So you can host the logical apps 4G on the same server, 5G CU on the same server, 4G DU. So this is a centralized unit and this is distributed unit. But this is for small enterprises. This architecture will be benefited for the small architecture. This is not a telco grade or for big operators. Okay. So that's why we are merging everything in one equipment. So 4G DU, 4G CU, 4G DU, 5G DU, small cell, core, ONM, and any other third party integration that also will be any third party application will be treated as a logical apps in Rakuten Symphony simplified small enterprise grade architecture. So now you can understand the one server will have everything. Okay, And now you can consider the traditional RAN setup where you used to have the different servers for the core, different setup. So here now you can see if one server is having everything, then you don't need any transport network, right? You don't need to make a fiber line from one location to other location to connect your RAN to the core, because core in the same server. Okay, so the no uh, uh, transport media is required in this small enterprise setup. Distributed unit on the same, centralized unit on the same. Even a small cell can be in the same. Even ONM, operation maintenance, can be on the same server. All right, so you don't need to deploy the different servers managing the network from different location. The same location you can manage it. But this is called network in the box solution. One box, one server, everything inside that. Okay. Hope this is clear. It was just to simplify for you guys that how own and simplified architecture look like, and now you can compare how it is fast for go to market, and how it can be efficient, and how it can be capex and opex wise, how it can be efficient, right? Very very cost effective. uh, the next part is uh, the three different scenario I explain you. I try to explain you here. The first one is general architecture, what we are offering to the customers, and also what we are offering for the lab setup, because multiple places for multiple operators we are doing the POC in their lab. So that is what we are offering. And the next one is RMI field deployment. So this is the deployed grid scenario. So we deployed actually this architecture in Rust and Mobile, and this is how it's the every equipment has been deployed, and we are getting the world class virtualized, best user experience, best throughput, best download and upload throughput through this commercial deployment. So let's start with the general architecture. So again, uh, this I wanted to show you. If you don't know the Open RAN and virtualized RAN, so this is for you, and you can now compare in for traditional RANs. You used to have this part on the site. Okay, this DU and the CU. Earlier it was the BBU, baseband unit, but now it's distributed and virtualized. I will tell you the advantage of virtualization in a minute. So now you will have very less footprint on the site. That will be only antenna and the radio. Okay, nothing else. But and this radio will connect to different. So we are deploying different data centers. This is is data center, a small data center nearby the site, and here we are uh, hosting the DUs. Okay, it can be 5G DU or 4G DU. So our architecture is same for 4G and 5G. Okay, there is no difference. Now the interface from DU to ORU will be the EC3. This is the ORAN base. So basically, the 7.2x split is from ORAN. This split give you the advantage to use any vendor from here or any vendor from here. If it is not 7.2x, then this vendor cannot, the multi-vendor scenario cannot be exist. Okay, so this is from Open RAN. Same, you can see here the same front haul mechanism we are using in 5G. Now in the regional data center, we can deploy the CU. Okay. Interface name is changed. Here we have the W1 mid-haul interface, but here it's a front. It's a F1 mid-haul to connect the DU with the CU, and then we can connect the OSS and RIC from this, and finally it connect from S1 backhaul interface to the EPC and NG backhaul to the NG core. If it is 5G core, then it will be NG core, right? So now let me tell you, if you have question uh, what is the advantage, the traditional used to have everything on the side, now you have distributed everything. So what will be the advantage? So the first advantage is here that the footprint on site is very less. So you require very less power on the site. So no issue or no any issue with the landlord or any location wise, because some locations you don't allow to construct the big size towers. So our setup can be deployed on single pole. So it can be street pole or any wall because the footprint is very low. So first advantage is here. The second advantage is the one server DU. Okay. So this is one server. Now here you can have 12 DUs. Okay. Now this is a advantage of virtualization. If you have this on the site, what it means, one DU you will use for one site. But if you have virtualized it on data center, now 12 DUs, okay, or in one server, there's a one server, so 12 DU can use. What it means you can connect to 12 sites. Instead of one site, you can connect it to 12 sites. So cost effective, it will give the efficiency cost wise, operation wise, right? The equipment wise. Now why we have not put CU on the same location? You might have this question. Why we have further centralized the CU? Because one CU will host 24 cells and one 5G CU will host 256 cells. Okay, so you can compare 256 cells. This one CU can be managed. All right, so it means this ORU, if this is one cell, so just divide by 3, 256 by 3, that many of cell site you can handle from one server, one CU server. Okay. So for CU, not even one server, one fraction of server, because this will be the VCU. All right. In one server, you will have 9 CU servers. Nine, sorry, let me repeat it so that you will not confuse. In one server, you will have in certain condition, you will have 9 VCUs, 9 centralized unit, means 256 into 9. Now you can compare one server and that much of cells. Okay. So this is the advantage of virtualization. Now you can easily understand why we are not keeping everything on the side, why we have virtualized. This is the advantage of virtualization. Hope I'm clear here. Let's go to the next one. In the lab setup, we have different emulation and servers, which is for the different test cases scenario, the ORAN, the code test, the test plan test, the ODU test, the ORU test, the OCU test. So everything is we are doing, and also the end user simulation. We are keeping here in the box, and we are performing all the functionalities. And this is actual deployment what we have did in the RMI. So as data center, we have deployed the VDUs, okay, and in the regional data center, we have deployed the CUCP. So in the 5G, the CU functionality will be further segregated in the CUP user plane and the control plane. And also the EPC functionality is in here only. So core functionality we have migrated to the RDC, and in centralized data center we are only keeping the 5G core applications along with the IMS and other IMS applications. All right, and you can see everything is virtualized because we are virtualizing it through the SIM cloud. SIM cloud is Robin.io. All right, just to explain you the split wise, this is RU which will be deployed on the site. This is a DU. Okay, there's a DU here. It's DU deployed, and protocol wise, what we are having inside that. So mainly the layer 2 protocols we are having here, and this is a layer 3 protocol and some part of layer 2 protocol, but the functionality is differentiated or segregated in CUCP and UUP. CP is control plane. All the control plane will be handled here, and all the user plane will be handled here. And this is for small cells. So small cell, the DU and RU will be inside this. This is a integrated DU. We will connect through the middle, and the CU will be the same what we have discussed here. Okay. So again, for 4G there will be one CU, but in 5G the CU will be like this in a small cell as well. If you're having the different options following the different options, this for a small cell option 2, the CU, and it will connect to the Ethernet cable or any available media, fiber media, and then you can have the small cell DU and RU. So you can see here very small unit. It's kind of Wi-Fi unit, but it's equipped with the DU. All right, and this is from Sercom. This is third party, and this is from Rapid and Symphony. Server is from Supermicro. Okay, it's a different company, no vendor locking, but the operation is cost efficient, better user experience, better quality, better download speed, best go to market speed, because in less time you can deploy more and more network because of automation. Okay. Now the cloud which we are offering to the customer is the Robin.io, or you can use any cloud. So what advantage is, traditionally legacy was this radio and baseband unit, everything on site, right? But now this is the old one where the virtualized network functions used to be like this, but our Robin Cloud support both. Okay, so if I'll give you just quickly the difference between the other cloud and Robin.io. Other cloud means AWS and Google and other. They can only support this architecture, this cloud native architecture, but Robin.io can support this as well as this. So the advantage would be, if some operator have deployed the OpenStack architecture, they have virtualized already, but on the OpenStack, on the virtualized network functions, our Robin.io can support that, as well as they can offer the new one. So both will run simultaneously. Okay, so just to engage with the existing setup, we are offering this functionality to the customers. This is a simple example how the BNF is deployed and how the CNF is deployed. Okay, these are some, so sorry. So this is a simple example of benefit. Just give me 1 minute. I need to take some water. All right. So this is simple cloud benefit. We are offering no or low code Kubernetes for all the deployment. It's including day one, day one, day zero, day one, day two. If someone is not too much technical, it's all the deployment cycle, starting from beginning to end. We are supporting, so any engineer with the low Kubernetes knowledge can use our cloud. This accelerate the deployment on automate the deployment and management. It has very low footprint as and offered the high performance. Okay, so this is perfect for the edge use cases, edge applications. We are giving the high performance. At the same time, we are reducing the capex and opex, the capital expenditure and the operational expenditure, and we run the VMs alongside the containers in one common platform. That is what I was telling here. This is possible through Robin.io only, or SimCloud, not through any other cloud platform. This is the advantage of SimCloud or Rakuten Symphony Cloud. Now the final slide on the sim world applications, or the automation, full-fledged automation in 5G, which we are offering, or which the operators can leverage. So this is simple cloud platform. On top of that, you will have the RAN, let's say the 5G RAN, which I just explained you, and on that we will have the platform, and on the platform you can deploy the different symbol applications like Simplan to plan your network, Symbil to build your network, SimOps for operation management your network. So these are the further applications which you can use for automate your monitoring, automate your building process. Building process means you're installing the site, you're installing data center. How you will automate? So this will be possible through Symbol. Simplan will be how you're planning the network, and your update, your upgrade can be done through here. And Simplus is for drive tests. So earlier you used to have Temps or Mentos or any other. Now we have our own Simplus which you can use. All right. Other one is for business and customer care services. This all is again automated.